All right, so something that we have seen elsewhere in the course, but comes up on the circle as well, is the idea of x and y intercepts. Where does a graph cross the x and y axis? Okay, so we can be asked this about straight lines, about parabolas, about kind of U-shaped and upside down U shaped curves, about cubic graphs as well with the two turns in them, and we can be asked them about circles as well. So if I was asked, where does the circle x squared plus y squared equals 16 cross the x-axis? So it crosses the x-axis here and here. We might be able to figure this one out a different way just because we can work a radius out quickly, but just to show you doing it this way. Well, any graph or any curve or line or anything crosses the x-axis where y is 0. So it crosses the x-axis on the x-axis. So that means you haven't gone up or down. So you haven't gone up into the y's or down into the y's. So your y is equal to exactly 0 along this line because you haven't gone up or down on the graph. So what you were going to do is sub in 0 for y. So it's just the other way around to what you might think. So something crosses the x-axis where y is 0. So x squared plus sub in 0 for y. So you get x squared, 0 squared is 0. So you just got x squared equals 16. So something multiplied by itself is equal to 16. Issue with doing this in the calculator is only going to give us one answer, but we need two answers. So we're looking for the 2 points where it crosses the x-axis. So yes, 4 squared is equal to 16. What other number multiplied by itself is 16? Well, it's minus 4. Okay, minus 4 squared is also 16. So 4 squared is 16, but minus 4 squared is also 16. So just if you're kind of solving something with a squared and you're looking for a second answer and it doesn't maybe seem obvious where that second answer is coming from, maybe consider that negative case as well. So x is equal to 4 or x is equal to minus 4, because 4 squared is 16 and minus 4 squared is also 16. So we miss this one a lot, or we ignore it a lot of time as well, but that is also a solution to that. So the actual point then is 4, 0, or minus 4, 0. So that's 4, 0, and that's minus 4, 0. Okay. We also could have got that one by going the center 0, 0. The radius squared is 16, so the radius is 4. So kind of 4 directly out gets me to 4, 0. 4 directly out this side gets me to minus 4, 0. But we can also do it this way as well. All right. Slightly trickier example then is when it's a non-0, 0 centered circle. So like something down here. And we're asked, what are the y-intercepts of the circle x minus 3 squared plus y minus 1 squared equals 34? So if it crosses the x-axis where y is 0, it must cross the y-axis where x is 0. So this is this is the y-axis. So it crosses the y-axis where it's not to the left or right. It hasn't gone into the positive x's. The negative x's is on x is equal to 0. So sub 0 in for x. So 0 minus 3 squared plus y minus 1 squared equals 34. So 0 minus 3 squared is minus 3 squared, which is just 9. Okay, so minus 3 squared is plus 9. So don't forget, brackets minus 3. If you're putting that into the calculator, it's like that. If you don't put the brackets in and don't enter it exactly like that, it's going to give you the wrong answer. So that is 9 plus, we've got y minus 1 squared equals 34. There's two ways you can go when solving this now. So I could multiply this y minus 1 out, and it'll give me y squared minus 2y plus 1, because don't forget y minus 1 squared means y minus 1 times y minus 1. So you'll end up with a quadratic. You'll solve it, you'll get your 2 points, okay? Just a slightly different way of solving this one. So suppose we could informally look at it now and go 9 plus something is equal to 34. So this is equal to 25. I'm looking for the y that's going to make this squared equal to 25, or just to do a little bit of work before I get there. Bring the 9 over, so leave it as 9 minus 1 squared is equal to, if you bring that 9 over, it's minus 9. 35 minus 9 is 25. So y minus 1 squared is equal to 25. All right, so something squared is equal to 25. So what squared is equal to 25? It's 5. So y minus 1 must be equal to 5. And if I bring the minus 1 over, it becomes plus 1, and I get y is equal to 6. I'm looking for another answer here, though. So where's that other answer coming from? Well, again, just like up here, 5 squared is equal to 25, but minus 5 squared is also equal to plus 25. So y minus 1 could also be equal to minus 5. Bring your minus 1 over, it becomes plus 1. Plus 1 minus 5 is minus 4. So y is equal to minus 4. So my points are 0, 6, and 0, minus 4. All right, so this must be 0, minus 4. This must be 0, 6. If you had have multiplied it out here and solved it as a quadratic, you would have got the same answer. All right, I'll do it really quickly over here. So if you multiply this out properly, it ends up being y squared minus 2y plus 1. I've also got the 9 there, and I've got it equal to 34. So y squared minus 2y, 9 plus 1 is 10. If you bring the 34 over, it becomes minus 34. 10 minus 34 is minus 24 equals 0. And if you were to do that using the minus b formula or any other way, you'll get y is equal to 6, y is equal to 4. Okay, so that's just, if you did expand the bracket out and solve it that way, you'd get the same answers. Okay, so 0, 6, and 0, minus 4. I'll just do one more example over here. So where does x plus 1 squared and x minus y squared equals 26 intersect the y-axis? So intersects the y-axis where x is equal to 0. So put 0 in instead of x. So this is going to be 0 plus 1 squared plus 9 minus y squared equals 26. 0 plus 1 squared is 1 squared. 1 squared is 1. So this is 1 plus y minus 9 squared equals 26. If you bring the plus 1 over, it becomes minus 1. 26 minus 1 then is 25. So I get y minus 9 squared equals 26 minus 1 is 25. And I've got a kind of similar situation as I had down in this question here. So I could multiply this bracket out and I'd get a quadratic, and I would use probably minus b, or you could factorize it and get your two solutions for y. But you can also say something squared is equal to 25. So this something, this y minus 9, must be equal to 5, or else it must be equal to minus 5, because minus 5 squared is also 25. So this, bring the minus 9 over, 5 plus 9 is 14. Bring the minus 9 over, 9 minus 5 is 4. So 14 and 4 are your two y values. So your points are 0, 14 and 0, 4. All right. Common enough question as well, just to kind of touch on it here. You get asked on the circle, is sketching the circle. So I'll just do it roughly here. You obviously have to do it properly in the exam. So if you were asked to sketch this circle, what information do you need to sketch a circle? You need the center, either the center and the radius, or you need the center and 1 point on the circle. Well, I know the center of this circle. So if it's x plus 1, then the center must be minus 1, y minus 9 must be plus 9. Okay, so remember, it's these things in the brackets with the x and y, the h and the k, if you're using the formula on page 19 of the log tables, that gives you the center. So you just change the sign. So minus 1 plus 9 is the center. So if you were drawing this thing, minus 1 plus 9, let's say it's around about there. So you would put the point of your compass on minus 1, 9, and then say 0, 4 is here. Put your pencil there and just draw the circle then from there. So obviously I'm doing it roughly. All right. So point on the center, pencil on the point which is on the circle. Okay. So where it crosses the y-axis, and just draw that circle around. Or else you could have gone point on minus 1, 9, and pencil on 0, 14 and draw the circle. Okay, again, obviously in the exam you do this properly with the ruler, spacing the points out properly, using the squared paper they give you, using a compass. But that's just roughly how you would do it. Okay, but the main message of this is x and y intercepts. To find where a circle crosses the x-axis, you let y equal to 0 and then solve for x. To find out where it crosses the y-axis, you let x equal to 0 and solve for y. All right, you should generally get two solutions. You could get them where they just touch the, so you could get maybe a circle like this that just touches the x-axis. So you can, it's possible to just get one solution here, but quite often you'll get two solutions like I've seen in the other examples. And just look out for that second solution. It's often because when, say, x squared is equal to 16, you need to look at +4 and also -4. All right, you can do it this kind of way. I was doing these ones slightly less formally, or you can square out the bracket and get the quadratic and do it maybe the way we've done it more often elsewhere in the course. All right.